So with a problem like this, some things we want to think about. If I have ab to the x plus k, and actually we can think about it being, well, this is actually being shifted to the right, so we could say that. This determines whether it's reflected up or down. So, and that's a positive number, this exponential equation will look like this. Within reason. I mean, because this is the 1/3 power, I guess I should say that it's going to look like a decay equation like this. Okay, but it hasn't been reflected around the x-axis is the deal. But because this initial value is negative, that tells me it's been reflected. So it's either going to be reflected down like this or reflected like this. So, and that's the case that's happening. Yeah, there's a left-right shift. I don't know if we really need to worry about that, because if it's x plus 1, it looks like that would be shifted left 1, but I don't think we need to know this for this problem. I see an initial value of 3, so that means it's going to be, normally it would be like this. Whoops, should be coming past the 2 like that, but it's been reflected because of that positive 3 in the front. And it's been shifted down 2. So the y-intercept certainly is going to be negative, so it's one of these, either A or B. And we could do some thinking about this. Let's see, if x equals 0, that's going to be negative 3 times 1/3, let's see, 0 plus 1 is 1, minus 2, so negative 3 times 1/3 is negative 1, minus 2 more will be negative 3, so we know it is definitely either A or B because of that. And then it starts down on the left and gets closer to y equals negative 2 on the right, because that's the horizontal asymptote. So it starts down on the left, approaches y equals negative 2 on the right. So I'm saying A. I hope that kind of thinking helps, wasn't confusing and helps you out. So I'm looking at an exponential equation. Since this is multiple choice, I can kind of cut myself some shortcuts. All 4 of these has 2 as the base. So when I take x, I'm going to substitute in, like for example this first one. I know it's going to be 2 raised to something minus, so 3 minus 2. In fact, they're all like that, so that helps. Times some initial value plus some other number better be equal to 10. So let's think about what's happened here. I've got 2 to the first plus something equals 10. So, well, if it's 3, say. So what if I do this first one? That tells me 3 times 2 is 6, plus something has to be equal to 10. Well, if x is 4, that shift up down is 4, that actually works. So this is a possible answer. Chances are that is the answer. Let's see if it works here. So actually that would be the same thing. That would be 6 minus 4, which is 2, and that's not 10. And the 1/3, well, let's see, it'd be 1/3 times 2, which is 2/3 minus 4, which is not 10. So choice A is going to be the correct answer. So I hope you see my reasoning on this, because let me try another one for you. So here's the one I made up, and what I'm noticing here for this model is that these numbers, these y values, are increasing, which tells me this is an exponential growth model, which this equation, because it's got a 1/5 as a base, that's a decay equation, and that's a decay equation, so we can throw those right out. Now we're going to look at what's left, and I'm just going to pick some numbers. How about 2? How about if I use x equals 2? So 2 times 5, let's see, 2 plus 2 is 4, minus 3, well, 5 to the 4th is, what is that, 625, and 625 times 2 minus 3 certainly isn't 5. So it must be this is the model that'll work, and let's check it and make sure. So 2 times 5 raised to the 0 power plus 3, because 2 minus 2, if x equals 2, right, 2 minus 2 is 0, 5 to the 0 is 1, so 2 times 1 plus 3 is 5, and that is the model that works. So hope that helps you out.